So my name is Martin Riesel. I work for Merck. So the company outside of North America, it's called MSD. So don't be surprised if you see MSD in the agenda. So I'm responsible for the big data platform. So which means that we are helping Merck to process the data. So what Merck does? So you're probably familiar with that. So I'll just remind you, it's a pharma company. So the primary business is the research and manufacturing of drugs for people. So during that process, so we generate, we store, process a lot of data. It starts with all the research activities, so where we have to come up with the new ideas, prepare clinical studies, so do whatever is necessary to get to the patent and then prepare the drug for the manufacturing. Manufacturing itself, it's probably not that easy as manufacturing of cars, so where we have robots who do all the maintenance for you. So manufacturing in pharma could be a pretty complex process which takes so many days, and the result may vary, so depending on the batch. So the manufacturing may be so pretty difficult process. So marketing, sales, finance, that's probably similar to the other companies. As I said before, so we generate a lot of data during that process. So in pharma company, it's more difficult than in other companies because we are subject of regulation and validation. And it could be pretty tough. Just to remind you, the validation means that whatever we do, and especially in the research and manufacturing, so everything we do has to be properly documented. So all the steps, everything that has been done should be documented so that we can prove that everything has been done in a compliant way. So FDA, which is that US regulatory body, or Europeans, and it can be very different in every country. So they watch that pretty closely. If we do a mistake and so on, so it can result in big fines, or even they can stop manufacturing of some drugs. But it's not only the financial penalty. So we are talking about the people's lives. So again, it's very important we do everything properly, we document everything properly. Yes. So, speaking about the inspections and about the proper documentation, so we have to also store that information, so we have to prove so when the inspection comes. Just for information, so we see increased focus on the inspections. During the last 5 years, so it significantly increased. It was about 80 inspections in year 2010. So last year, so we had almost 150 inspections. So what does it mean exactly for us and for the data processing? So during so every step, so we have to document what has been done, so which means auditing, logging all the information, storing all the information, for a possible inspection. When the inspection arrives, they also so need to see everything quickly, so which means so have proper indexes of everything. Since we generate a lot of data during manufacturing and research, so it also requires a lot of storage and a lot of processing power for all the logs and for the audits. So we are looking now into Hadoop platform because we believe it could help us to consolidate all the validation information and also the information that we have. Typical areas that we address in the big data platform is search. So that's one area that's very important, especially for the research. So while you're using Google to search through the internet, so we have to develop some more functionality because we have to index also pharma-specific content, so which means like chemical formulas and so on. We also recently started looking into open data, so which is data that are published by various governments and are otherwise publicly available on internet. Social media, so that's also part of the information that we can leverage when doing research of new drugs. Data integration, that's a very important part of what we are doing, because in a pharma company, we have large volumes of data in some areas. In other areas, it's not probably that large volume, but it's very complex data. So we have hundreds of systems, so very different. Some of them are legacy that can't be simply changed, but so we have to take the data, and so we want to run a lot of analytics across the whole company to improve our business. So data integration is a very important aspect, so we also believe that Hadoop technology would help us. And since we are speaking here about the data governance, so data governance is an essential part of that process. Data analytics, I mentioned that briefly. So we are now looking into some very advanced analytics across multiple areas to improve the overall business. To give you an example, we have a problem, we call it 90 days. To give you an idea, so imagine that you get an order to provide new batch of drugs for European market. So it's not that easy that so you would just go there, so you would press the button and suddenly so there are pills coming from the machine. So you have to order from various suppliers, so the material. You wait until it gets delivered. Then when it gets delivered, you have to test it, whether so you got what you ordered and whether it matches all the requirements. So then you start producing that. So there are so I said it before, could be very complex, so manufacturing and so on. So overall, it can take more than 90 days, so to do that. If you know that, so you can react to it, and so you can start ordering so the drugs in advance. But there is another risk coming. So if you order too much and you store it somewhere, there is expiration time. And often it happens that so you just go beyond the expiration date, which means that you have to throw it away. Sometimes it's pretty expensive, and so it can result in pretty heavy loss, financial loss. So we are trying to run analytics project. The goal is to improve that data. In reality, it means to take data from various systems like SAP. So we have laboratory information management. So we have enterprise systems that so where we store all the orders. And so then we have finally the manufacturing execution systems. So we can collect all the data, and it could be so very large volume. It could be different formats. So we can have different information from different manufacturing. So we have to collect the data, so then we can run the analytics, and as a result, so we can get information that would help us to improve that time. So for instance, which suppliers provide or give us more reliable material, and so on. So that's one of the examples. So what we have to do. Again, since we are getting data from various systems, so we have to have very good data governance. Since this is for validation environment, and if we, for instance, decide that reconfiguration of the manufacturing process would help to improve that, so we have to prove to the regulatory body that, so this change will still, help us to produce the same drugs, and so on. So we have to document properly everything. So now I will hand over to Ivo. So Ivo is our architect. So he will deep dive into individual cases, what does it mean, the data governance. What are the important use cases for us? And finally, so we have Andrew here who will talk about Apache Atlas project, because so we as a Merck participate in the project. We believe the data governance that will be a result of the project will help us to solve some of our cases.
Thank you. Good afternoon. So Martin was talking about the concrete use case of reducing the period of the manufacturing time for the batch processing. So let's imagine an average data scientist who needs to address this problem, who needs to perform some analysis to propose some solution to the reduction of the manufacturing time. Before he can really start to deep dive into the data, he needs to solve several fundamental questions. One of them is where is actually the data I need for my analysis, because Merck is a huge organization. There are several or many different systems where you can look for your data. You need to aggregate them on one place, and often it's not really obvious where you can look for the data, so it takes some time to find out. Even if you find out where the data is located, you need to find the responsible person who simply is responsible for the data and can give you an access to the data sets that you need. Even if you find the person, you need to follow certain types of processes to get the approval, which again might be a really time-consuming task. And when you finally have the data, still it's not a win. You have to find out what actually the data mean, because often you can end up with hundreds of tables where there is no documentation about them and so on. I guess you are all familiar with this type of problems. And as we are working in the regulated environment, for us also, as Martin already mentioned, the reproducibility of the result is really the key part. We need to be able to prove the process, how we achieved some results of the analysis. So we need to take care of that as well. So in the next couple of slides, I will take a look how we address actually these questions. As an example, some time ago, we had a problem with manufacturing of our vaccines, and we needed our data scientists to take a look at the problem, to analyze the manufacturing process and find out what might be the root cause of the decrease of the quality of several critical parameters of the vaccine. And the sad story is that it took about 6 months to them to get to the actual data. So there was a 6 months between the period where the problem appeared and the point where they were actually able to look at the data and start the analysis itself. So we try to shrink this time period as short as possible. So the first question, how do you address that? We try to provide one common place where everyone can upload the data and share it with others. So we try to provide many connectors to several systems all across the company to load the data, to make it easy for everyone to upload the data to the data lake. And then we expose the data. We provide connectors for different analytical tools, visualization tools, reporting, full text search, and so on. We work with this concept of data sets and transformations, where data set is basically can be a set of files, or it can be a relational database. And the transformation is a set of operations that you can perform on top of the data. You can merge the data set, clean the data set, filter it. And so we try to cover all this ETL process so that the users can load the data, clean them, and then possibly share them with other people. The whole data lake runs on top of Hortonworks data platform. And on top of the data lake, we provide our own middleware layer, which provides the security and the data governance functionalities. But our aim is to shift as much functionality of this data governance to the Hortonworks stack itself. Also, having the data in Hadoop is fine, but you need a way how to find out what actually you have stored on HDFS or in Hive. So on top of that, we provide a web-based data catalog that enables the users to register their data sets and provide metadata about them, like description, tags, categories, and so on. And then we provide a full text search interface that the user can use to find the data set they actually need. So the problem of the ownership, We solve it currently with quite a basic model where we have the role of the dataset owner. That is someone who creates the dataset, is responsible for the data, for the maintenance of the dataset. And if anyone else is interested in the dataset, he simply asks this dataset owner, sends him the request, and the dataset owner provides the appropriate permissions so that the user can read the data from the dataset. As simple as that. For this model, we use ordinary access control lists on the level of HDFS files. But if you have many dataset owners in the system, this can be quite messy really soon. So we want to provide this kind of central authority, an entitlement steward, that is someone who is responsible for giving the access to the people, who actually knows all the processes that are needed to carry out to validate if someone is approved to read a particular dataset. So instead of contacting the dataset owner, the user contacts the entitlement steward, and the entitlement steward is the one who gives the permission to access the dataset so that the user can read the data. Also, the plain ACLs are fine, but it's not really enough for us to, like, the level of the granularity of the permissions that you can provide, because you can provide access to the whole Hive table, for example, but we need to more fine-grained access on the level of subset of columns or even subset of rows in the table. So we decided to use Apache Ranger as our policy engine. So in our case, the entitlement steward actually creates the rules in Apache Ranger to allow the access to the data. The meaning of the data is another important part of the problem. Actually, at Merck, there's a whole team of people who try to map all the data assets that the company has. What they do is basically drawing one huge UML diagram of all the data sets and the connections to the people who's responsible for the data sets. What is the common meta model of all the data that Merck deals with? So we are really happy about the Apache Atlas initiative that aims to provide kind of a meta store that is able to store this meta knowledge about all the data sets that we can possibly have in our data lake. So the basic concept is to have one common place where you can create the common ontology for all your data, and then when you have different information in different data sets, like in this example where we have a SSN number in one data set, then we have birth numbers in another data set, and both are actually personal numbers that can be used to identify people. So in this case, you might want to map it to a common concept of a personal number, and then you can approach this kind of information in the same way. Like, you can hide it from certain group of users, or you can disallow the access to all the data sets that contain personal information and so on. So let's look how the metastore fits in our entitlement model. Still, we have the dataset owner who creates the dataset, but at this time, the metadata from the datasets are uploaded to the metastore automatically. That means if you create, for example, a Hive table, the description of the table, like the name and the columns, is uploaded to the metastore. And then we have data steward, that is someone who is supposed to understand the data. He can read the data set and can provide the mappings to the common concepts in the metastore. And then we have, again, our entitlement steward, who in this case is able to read actually also the general concepts from the metastore and provide the policy rules based on these general concepts. So he can disallow the access to all the data sets that contain personal information, for example, for the user. So when the user reads the data, actually what our policy engine or Ranger does is that it looks into the metastore, matches the general concepts in the metastore with the data that the user is trying to retrieve, and checks whether the user is allowed to read it or not. So the reproducibility is another important aspect. We approach it in the way that we distinguish two types of data sets. One data set is, which is marked as raw data in this slide, is actually the stream of the changes that lead to the actual state of the data set. So in the case of a Hive table, this is a stream of insert, update, and delete operations that actually can lead to the actual state of the data set. And then we have a standard aggregation that is able to aggregate or merge all these changes and provide the actual state of the data set for reporting and querying and so on. And if new data arise, we store still the raw data, but we typically don't want to store all the copies of our reporting data sets because it is not the most efficient way how you can deal with the data. So we want to delete the previous version as soon as possible as we don't need them. But as we already said, we need to be able to reproduce the results at any point in time. So for us, it is really necessary to keep also all the metadata that describe the process, how we achieved the results that we achieved in the past. So we can delete the data, the reporting data set, as long as we are able to reconstruct it at any point when FDA asks us to do so. We can apply this even to more complex workflow that composes of multiple steps and multiple intermediate results. And for this purpose, we rely on Apache Falcon that provides this data lineage functionality that is able to draw this kind of graphs of the processing of the data where you have stored all the inputs that were used to get your results. And by the processes that work with the data, you are able to store metadata like the version of the code that was used to produce the results. So at any point in time, you are able to go back to this data lineage graph and find out how you achieved the results that you achieved. Another level of auditing are the access logs that come from Ranger in our case. This basically provides you with the information who accessed what and when and how, so that when something bad is happening, you are able to trace back who actually was responsible for the changes in our data lake. And the last level are obviously process logs, which are like, you all know the ordinary system logs that we archive and the logs from the processes or transformations that we run in our data lake so that we are, again, able to track back the execution. So that's just to wrap up. Here are our 5 fundamental questions that we need to solve to make the life of data scientists easier. And let's look how they map to the technologies that we use. So we use HDFS and Hive for the storage of the data, for the storage on one common place. On top of that, we currently use our own middleware to register the dataset ownership and additional metadata about the data, but we plan to shift to Apache Atlas, or the Metastore that is part of the Apache Atlas project. We use Ranger as a policy engine to manage our policy rules. And again, we intend to use Metastore to store this common meta model of our datasets in the data lake. And for the reproducibility, we rely on the data lineage functionality of Falcon. So having said that, I will pass the word to Andrew so that he can give you more details about what we actually do together.
Thank you very much, Ivo. That was fantastic. So, there.
Thank you.
Let's see if I can. Can advance. If you wouldn't mind hitting the button for me. So we have a few minutes left, and I'm just going to go over some of the constituent parts that are relevant for Apache, and how it makes sense and how it's rationalized with the requirements that these gentlemen talked about. Can you help me with the slides? Oh, okay. Yeah. Okay. So. For those of you who were able to attend the Atlas session earlier, I kind of glanced over, the relationship between our knowledge store, the flexible type system, and Ranger, right? So Ranger allows us to give or enable role-based authentication, right? So if you're part of a group, you get access to this bucket of stuff, right? And what we're trying to do is leverage metadata to give you a higher level of control, right? So a couple of things that we can do. We can do things like geography, and I think I talked about that in the talk, which is basically it allows you to, let me go to this slide. It allows you to create a policy based upon time. So if Ivo is accessing data from the United States and he gets access, jumps on a plane, goes to Switzerland or goes to Prague, there might be a whole different set of requirements regarding personal or sensitive information. We need to evaluate that based upon a different set of policies. We also have policies regarding time, so we can actually create safeguards for real-time access to make sure you're not in violation of like a SOX 90-day reporting rule. Something that I didn't get to talk about earlier was this really great use case that talked about entitlements, right? So the idea that we have this taxonomy with a structure where we have containers and we can inherit attributes is really important, right? So if we do our modeling correctly, what we can do is use this in a way that we can facilitate the entitlements, right? That makes their job a lot easier, right? You put something in the right place and it works. Now let's say we took the taxonomy and we took something from an existing standard like PCI, right? PCI has a well-defined vocabulary, right? And has a well-defined set of relationships, right? If we use that structure and we use that structure to create entitlements, well, guess what? You are going to have a lot easier time in terms of getting certified for PCI and making sure that you're in correct compliance, right? So these are just some of the advantages you can get, right? Now, to take that one step further, we can actually prevent violations, right? Because they have been very careful about the way the data steward tags the data, and then there's a whole separate person that handles entitlements. What we can do is create dynamic policies, right? We can say a tag that has certain types of information is allowed for certain types of users, right? So we can evaluate, role permission. You're part of this group, get this bucket of stuff, right? We can identify geography, we can layer upon that time, and now we can say, hey, if you are in a research department and you need to get access to this specific data and it's been tagged, late stage, trials, we can create a policy for that, right? The curator can just focus on curation because that's what they're good at. They're business domain experts, right? They don't have to worry about the policy. The policy person can take care of the policy stuff. And really, in a data lake, that's really the only way you can scale this model and do a good job, right? And because we're auditing all this stuff, it's not like we're in violation. We're tracking all of it. And because we created these very sophisticated access policies, now we're able to stop violations before they occur, right? We're not looking back, we're preventing them from going forward. So that type of integration is something that our competitors can't do yet. Maybe they will soon, but they can't. Right? And we're able to roll this out very soon. So in full disclosure, we're going to, did I have a, oops, I don't have the roadmap. But basically, they helped us with the minimum viable product for the release in Apache, which helped us incubate our project. That same set of features will be released for the general public as a GA release in HTTP 2.3. That's going to come out in a couple of weeks, I think. It's really based on timing. We're about done with it, right? So in that release, we will have a lot of hardening and a lot of testing done. So it's really going to be much better. And more importantly, where's Laurel? Laurel's right there. She is part of our awesome technical writing group, and she's going to make sure that our documentation is awesome, right? Yes, absolutely. Woo! And actually, we have our UX designer back there too. She's going to make sure that the UI, it's our first go at this, right? But the UI is going to be great, and it's going to get better over time. So with the help of folks like Merck to really drive the capability of the product, we're going to be able to give you something that's going to be usable right out of the gate, right? We're not going to have some kind of fuzzy product that you have to do a lot of work to make work to get value out of. We're going to give you something that you can derive value right away, right? So that's kind of it in a construct. If you have more questions about this slide, I can talk to you about it. I don't want to read through this because you've got a lot of PowerPoint presentations. So I can talk to you about that offline, right? But really, what we really want to do is we really want to make governance is driving this metadata. Metadata is enabling us to do this. Metadata is also something that we're going to use to unify and really get control over all the different components in HTTP. There's like 26 of them, right? Do you want to connect to all of them and maintain that type of relationship? It's very difficult. We're going to do that with Atlas. And in doing so, we're going to be able to provide an interface point for the whole platform. So if you have an external system, you can get data from Atlas and you can push data out to Atlas, right? And that's really the key. We're gonna start with governance, but we're gonna enable much further agility, like entitlements, like stewardship, right? And you really need this as a precursor to something that they probably were about to say, but they didn't, which is self-service, which is really the holy grail, right? And you can't do this effectively without having the pieces in place to allow that to occur safely, right? Anyways, that's the last of my slides. We have a few minutes for questions. Sir?
Is the data steward a person that has to massively put information into the meta store, or is this like a development requirement?
Okay.
People put that kind of data in.
Great. If I can repeat the question, and basically it'll give me time to think about the answer. Basically, the question was, data steward, is that a person? Is that a process? What is a data steward, right? So would you like to take that, or would you like me to take a stab at that?
Well, it's a role of the user of the system. So the data steward can be a dedicated person who simply understands a group of data sets, or it can be the data set owner himself if there is no one else who can describe the data. Basically, it's a user role of some user that is allowed to enter these entries to the metastore that is able to describe a particular data set. So there is not a single data steward typically in the system. It's a role, and you can have multiple data stewards.
And on your reproducibility
Mm-hmm.
chart, how do you do the transaction of changing to a new version?
Okay, hold on, let me just repeat the question. Reproducibility chart, how do you do the transaction of, what was that last bit?
Rolling to a new version.
Oh, rolling to a new version. How do you maintain the lineage in that transaction?
The
reproducibility?
Yeah, I remember that, but to the new version of.
How do you do the transaction? Somebody's consuming your original version. How do you do the transaction to ensure everybody's finished?
Yeah, that's like a feature of the middleware layer, which basically provides, which basically controls the run of the process that produces the data. And for example, in case of the Hive tables, we basically, the versions of the data sets are partitions of the Hive tables. And then when we provide a new version, when the process is ready, we have a separate view that points to the current version of the thing. And when the version changes, we just switch the view.
Yeah, this is probably a good time to interject with a quick comment, which is for our GA release, we have I told you that we're going to interface with all these different components inside of Hadoop, and I talk really fast, I better slow down. We have a lot of different components in Hadoop, and we want to interface with all of them, but we're going to start off with Hive. So we have a thing called a Hive bridge. So we connect to Hive, the Hive metadata store, and we suck in everything that it has, and then we're able to annotate that with additional business classification. But then after that, we have a thing called a post-execution hook. And that basically gives us all the transactions that have occurred in SQL. So they've developed a very sophisticated process to handle this, but we're also going to be able to do it straight out of Hive Server 2. Right? So I know everything that's occurred, the duration, whether the query was successful or not, and I'll even be able to parse the actual SQL to tell you, Ron over there did this crazy join 5 times last week, and we have no idea why he did that. So let's investigate. So we're going to parse that and make that available to you. Question, sir. Oh, this guy is trouble. Yes, sir.
So do you mean with the new architecture, with Atlas, or before?
So I want to know how many times you actually adopted. You're obviously working with Atlas today, or you're actually trailblazing with it. So how many audits have you had to facilitate using this new approach so far, so that you can validate that your data lineage and processing don't have any gaps?
Okay, so actually maybe I can kind of repeat the question for everybody else, which is how many times have you been audited with our basically the new solution with Atlas? And let me kind of save them a little bit of concern. They haven't done any yet with the new architecture. There's a number of things that we're building, and we're going to roll them out very soon. They're really helping us define the product. They're a pharmaceutical company. They have a long development cycle. They're very, very careful in what they do because there are big stakes involved. So I think maybe I can hand that over back to Martin if you want to add anything.
Yeah, as Andrew said, so the whole solution, we are still working on that. So we haven't had any inspection on the new environment because we still don't have production data in it. But so once we start putting the production data, it should be ready for all the inspections. So we are working with our experts, so before we even put it into the production, so we'll have to basically do our internal inspections, so to prove that it's ready for the prime time.
Yep. So that's basically.
And for us, sorry
no,
to
go ahead.
interrupt you. So for us, the most important part is to do that right. Then, so if we discussed all the trade-offs, so it should be the proper solution rather than do that fast.
Yep. So basically, the barometer, the tests that we would have to pass in terms of those audits are exactly what we're doing for the internal side. So we haven't done it officially, but we have done them unofficially. So that's probably the more diplomatic answer I should have given you in the beginning. So, any other questions? Oh, yes, sir.
In your process logs, do you have analytics that run through there to ensure that every step in the process was followed, or do you have any manufacturing?
This is again a work in progress. Currently, we have a solution that aggregates the logs so that we are able to access them in a unified way. But yeah, we then typically will want to aggregate them, make them better searchable, and then perform some automatic analytics.
Yeah. So within the Hadoop stack, for it's going to be in time for our HTTP 2.4 at the end of the year. We're going to have a process by which we collect actually all the logs in the whole stack, and we're going to make it searchable. Right. After that, we're going to make it taggable with metadata, so we can get additional insights and create, better insights that way. So there's a number of workarounds, but we're actually drilling into that specific scenario. Any other questions? Yes, sir.
So you mentioned taxonomy.
Yes.
So is that something that Atlas is going to handle taxonomy that you can apply to Hive, to all your data?
Hail a taxonomy. It's not like hailing a taxi, but yeah, exactly. So this is kind of a fine point, and generally I talk about this for a little while, but there's two concepts of models, right? So we can model a business. So we can model a retail company, so that would be stores, products, inventory, customers. And we can also model an energy company, right? They have oil, wellhead sites, they have big ships that carry a bunch of stuff across the water, and they have a whole totally different way that their business operates, right? So what we need to do is be able to have a flexible system that models either one of those, right? But at the same time, we also have to model specific components. So we're shipping Hive out of the box on our GA release, and so we model Hive. So that means database, table, column. Pretty straightforward, right? So for Kafka, we're going to model topics and messages, right? So, and then we also have access patterns. How do you access that information? So you submit a query, there's some planning that happens, there's an execution, and then there's a post result, right? So we model all of that. The benefit of what we can do, because we have that flexible type system, is that we're able to marry them together and give you that additional insight, right? So that's really what we can offer. So I don't know if you saw that in the other slide, but there's a bunch of different verticals, and there's a bunch of different models or taxonomies to address. And rather than putting them all together and trying to create this big system like MOF, if you're familiar with that, we really want to create something that was agile, right? So instead of creating like Noah's Ark, we created something simple, like a replicator that can match just what you need. So if you already have a modeling system, we can make our model match, so we can import data and export data easily, right? And if you want to meet the PCI standard, like the example I gave earlier, you can use that as your base model. And then you can add more tags later, right? Great. Any other questions? I think we have 34 seconds left. Thank you very much for your time. I know it's late in the day. Much appreciated.
Thank you.
Thanks to Merck.